That's an amazing question and example. Now let's get on to the last rule for the day. This is just the introduction to integration. We will cover other rules in our future videos, so make sure to share, like, and subscribe so that you don't miss out. So the rule for integrating sums and differences of functions. In this rule, we are saying if f of x and g of x are functions, then the integral of f of x plus or minus g of x with respect to x is equal to separated integral of f of x dx plus or minus the integral of g of x dx. That's how it goes. Now let's look at an example. Example 4. Integrate a, b, and c. So for a, we are going to separate each term. So we have x cubed plus 7 x to the power 1 over 3 dx minus the integral of 1 dx. We have separated this, and then integrating individually, we are going to get x to the power 4 over 4 plus 7 times x to the power 4 over 3 divided by 4 over 3 minus x plus 1. Remember how we integrate the constant, so 1 becomes x, and we add 1 and divide by the new power for the other terms. Now, of course, we cannot leave our answers unsimplified. So take a note, 7 over 4 over 3 is the same as having 7 times 3 over 4, which is 21 over 4. Now, substituting that back into what we had, we are going to have our final answer as that. So I hope it's clear. If it's not, write in the comment section so that I attend to it. Now, looking at example B. Right, so with example B, because we haven't covered how to deal with the multiplications yet, it is wise for us to expand the brackets first, and afterwards we integrate using the sums and differences of functions. So in this case, if we expand the bracket, we are going to have 6x cubed plus 3x squared dx, that giving us that, and we separate the integrations, in separating the terms, we would get integral of 6x cubed dx plus integral of 3x squared dx. That would give us 6 over 4 x to the power 4 plus 3 over 3 x cubed plus c. Now simplifying that, we would get 3 over 2 x to the power 4 plus x cubed plus c. So that is how we would get to our solution. So now we still use the same constant of integration, because remember, no matter how many terms we integrate separately, the constant of integration remains the same. It's just 1. We don't have 3 of them or 2 of them. It's just 1. Right. So we move on to B. We've covered B, so we're moving on to the C. So moving on to C, we are going to multiply, expand the brackets once again, but remember from the laws of indices, if we have 1 over x, that's equivalent to having x to the power minus 1. Now, if we consider that and we expand our bracket, we are going to have 3x to the power 2 minus 1 plus x to the power half minus 1 dx. And remember, we have over 3, so from the rules of multiplying with the constant multiples, we can take out the 1 over 3 outside the integral function and deal with what's inside, so that we have 1 over 3 times the integral of 3x dx plus the integral of x to the power minus half dx. Now, with that, we add 1, we divide by the new power. So what we would have is 1 over 3 outside the brackets, and inside we'd have 3 over 2 x squared plus x to the power half divided by half plus c. And that would give us 1 over 3 times 3 over 2 x squared plus 1 over 3 times 2 over 1 times x to the power half plus c. Now simplifying that, we have 1 half squared plus 2 over 3 x to the power half plus c. Now, we still have the same constant of integration. If you have made it thus far, congratulations. Your feedback is always welcome here. So make sure to share your experience in our sessions, your preferred numerical future topics, your questions, concerns, and suggestions. And if you haven't already done so, make sure to like, share, and subscribe. Thank you so much for watching Numbers Simplified. God